Binomial and normal distributions. There are two types of distributions: the binomial and normal distributions. These distributions are used for us to determine the probability of an event. The binomial distributions refers to the discrete random variables. For example, for the variable x equals to 0, 1, 2, and 3. There will be finite amount of the independence event. That means there will be a limited numbers of independence events, and within each event there will be only two outcomes, either successful or unsuccessful. The successful probability is determined by the p, while the probability of not successful is represented by the q. Knowing the probability of an successful outcome, the probability of failure can be determined by minusing 1 with the probability of successful. Based on the concept of the binomial distributions, the probability of P and Q will be always the same regardless how many times you try. Let's say now for a successful event equals to 0.3. We know that unsuccessful will be equals to 0.7. And the P will always remain as 0.3, while the Q will always remain as 0.7, regardless how many trials that we have conducted the experiment. And the expected value for the binomial distributions can be determined by multiplying the number of events with the successful probability. The equations for the binomial distributions is given here. NCX, the functions of combinations, multiply p power x and then multiply q power n minus x. The x here is a discrete number, and the n here is the total numbers of events. To determine the binomial distributions for a specific numbers of n of events, the probability of number of successful x can be substituted into the equations for 0, 1, 2, 3, 4 and onwards until the end. The value obtained here can be plotted in a normal histogram, which looks something like this. Each bar of the histograms are independent to the other bars. They are not continuous. Now we look into the normal distributions. The normal distributions is meant for the continuous random variables, and there is an infinite amount of events where the n is equals to the infinity. With this, the curve for the normal distributions will be smooth. The data here are evenly distributed, and it is symmetrical at the mean value, and the total area below the curve will be equals to 1, as represented by the equation here. Interpolations of the curve here from negative infinity to infinity will be equals to 1. The normal distributions can be used to represent the cases that we encounter in our daily life. For example, the distributions of people of different weight and height. We will have a large amount of people of the normal weight and height, very less amount of people with extreme height and the extreme weight. If the sample data is unlimited, we will expect a smooth normal distribution curve. The curve for different situations may vary each other in terms of the mean, standard deviations, the values and the units, and also the area between the curve and the horizontal line. In another word, the curve can appear to be very slender and tall, or very wide and short. Depends on the situations. However, all this curve has a common characteristic. The curves are symmetrical both sides and separated by the mean. The curve is smooth. It is taller at the mid while shorter at the both ends. The standard deviation here will determine whether the curve is slender or wide. Large standard deviations will give you a wider curve, while small standard deviations will give you a taller normal distribution curve. Regardless whether it is wide or tall, the area below the curve will always be equals to 1.0. Here is an additional knowledge on the standard deviations. Based on the group data obtained, we can compute the standard deviations, and it provides indications of the percentage of the samples falling within different regions of the normal distributions. What you see here, this is the mean of the data. The standard deviations -1, 2, and 3 is indicated here, and standard deviations 1, 2, and 3 is indicated here. The 1, 2, 3 here indicate the times or standard deviations. You will expect 68% of the samples will fall between 1 times the standard deviations range. For the range of ±2 standard deviations, you will be able to obtain 95% of the confidence level. And if you have 3 ± standard deviations, you will get 99.7% of the samples, or the probability. Although the curve can differ each other in terms of the mean, standard deviations, units, and also the area below the curve and the horizontal line, a standardized normal probability curve can be obtained in the functions of the standardized value, which the z here is quantified in terms of the mean and the standard deviations. Through this, we are able to use the standard normal probability curve for us to compute the probability of situations. This will be discussed later in the example questions. Once you have obtained the z value, you may refer to the normal distributions table to obtain the probability of the cases.